Resource-based constrained delegation. In the previous section, we had discussed constrained delegation within Active Directory that empowers administrators to control how services and systems delegate user authentication and authorization. The resource-based constrained delegation takes its concept a step further, offering even fine-grained controls and security. We will explore the significance of resource-based constrained delegation, its benefits, configuration, and how it strengthens Active Directory security. In traditional delegation models such as unconstrained delegation or constrained delegation, administrators typically configure delegation settings on the accounts that need to delegate their authentication rights. This means that if user A wants to delegate authentication to service B, settings related to this delegation are primarily configured on user A's account. Resource-based constrained delegation, on the other hand, shifts the control and configuration to the resource or computer account itself. Instead of configuring delegation settings on user's A account, RBACD allows administrators to specify which accounts are trusted to delegate on behalf of the resource or computer account. This means that service B in this case can dictate who can delegate to it. Now let's talk about a property called MSDS allowed to act on behalf of other identity. At the heart of RBACD is the MSDS allowed to act on behalf of other identity attribute. This attribute is associated with the resource or computer account that needs to delegate authentication. It stores a security descriptor that defines which accounts or entities are granted the privilege to act on behalf of the resource or computer account. The security descriptor within the MSDS allowed to act on behalf of other entity attribute includes the following key components. First up, we have trustee. The trustee represents the entity, example user or service, that is trusted to delegate on behalf of the resource. Next up, we have rights. The rights specify the actions that the trustee is allowed to perform on behalf of the resource, which typically involve authentication and authorization. Next, we have inheritance and propagation. The security descriptor may also include information about these rights are inherited or propagated. And finally, we have scope. The scope defines the boundaries within which the trustee's delegated rights are applicable. Now let's see the attack scenario. To execute an RBACD attack, an attacker must meet specific prerequisites. Firstly, they require control over an object that either has service name principal or service principal name configuration or possesses the capability to introduce a new machine account into the domain. Additionally, the attacker must hold write permissions for the target computer. Let us look at RBACD scenario in our lab. Open a Bloodhound and search for the user Jordan Carey. If you remember, we had obtained the password of Jordan Carey by dumping the LSA secrets. We had also cracked the password of the account SBC EDR through targeting curb roasting in the previous section. Upon further observation, we can see that the SVC EDR is a member of services group which has add allowed to act privileges on the domain controller. This means that this account happens to have write access to the MSDS allowed to act on behalf of other identity attribute situated on a domain controller. This level of access is attainable due to inadequately configured Active Directory permissions. Remarkably, the attacker's sole purpose requirement is the ability to modify the attribute on the target computer, which is feasible due to the presence of poorly configured Active Directory permission. It's noteworthy that by default, all users possesses the capability to create up to 10 computer accounts, a quota defined as a machine account quota. This makes the tasks involved relatively straightforward even for a non-privileged account. Performing a resource-based constrained delegation RBACD attack involves a series of steps, and each step plays a crucial role in achieving the attacker's objective. Let us break down the process in detail. In the initial step, we create a dummy computer account within the target domain. The purpose of this dummy computer account is to serve as a platform to manipulate delegation settings. Impact it at computer, then specify the computer name RBCD $, computer password as can be seen on your screen, then the DCIP, then we can specify the name of our domain /svc EDR user, then its password as again mentioned on the screen. In the next step, we need to manipulate the delegation settings by populating the MSDS allowed to act on behalf of other entity attribute of the dummy computer account with the security descriptor that grants a specific permissions. We can use the impact RBCD tool to perform this task. The command includes impact RBCD, then the flag or option delegate from RBCD, then delegate to DC, then DCIP. Action we can specify as write, then specify the name of the domain /svc_username, svc_edr as the username, and then the password Kate_1983 as specified on the screen. In the final step, we obtained an impersonated service ticket for a domain controller. The service ticket will enable us to impersonate the domain admin. We can use the impact get service ticket tool with the following parameters. We can use the impact get st tool with the following parameters. First up, we have -spn, which is cifs/dc.insecurecorp.local. Then the flag impersonate godfather, which is the domain admin. Then we can specify the DCIP. Then the name of the domain / the computer account which we had created, which is RBCD $. Then the name of the password of this account, which can be seen on your screen. After successfully executing this command, the attacker obtains the impersonated service ticket and saves it to a cache file named godfather.ccache. Once that is done, we can leverage the impersonated service ticket of the domain admin godfather obtained to abuse the resource-based constrained delegation and gain unauthorized access to the target system and dump the hashes from the domain controller. We will look at how this can be done in a later section. Further, you can try RBCD attack against the pentester machine also with the credentials that we created while performing the WebDrive relay attack, which we had discussed in a previous module. In summary, the RBCD attack involves a carefully orchestrated sequence of actions starting from the creation of a dummy computer account to the abuse of delegation settings, ultimately leading to unauthorized access to the target system. It is imperative for organizations to implement robust security measures and monitoring to detect and prevent such attacks effectively.